the rectangular transition. Here we have a rectangular transition. The finished length is 9 inches. We have an instruction telling us that the bottom is rising 2 inches from the 8x10 end to the 6x12 end. We can see that the right side is offsetting 3 inches as well. And another observation is that we have duct mate 25 on the 8x10 connection, and we have an S and drive transverse connector on the 6x12 connection. The first thing we need to determine with the rectangular transition is its working length. This is extremely important because without the correct working length, this fitting will not turn out as we want it to. So, we have a 9-inch finished length. We have duct mate to consider on one end, and we have S and drive to consider on the other end. Now, let's just take a look at this. We have a working length of 9 inches. We have a duct mate 25 connection which requires 1.25 inches straight. Now this straight has to be subtracted from the finished length as I've got drawn here. And on the top we need to interpret a 1-inch allowance for a duct mate connection that divides up like this: material line, finish line, working line. Now the working line is 1/2 inch away from the finish line, so let's just do some math here. We have 9, we need to subtract 1.25 inches. From that we need to subtract another 1/2 inch to accommodate the duct or the S and drive connection. Leaves us with a finished working length of 7¼ inches. Now what does that mean? That means that to make this fitting 9 inches long, I need to make the transition happen over 7¼ inches and then add my allowances for the duct mate and the S and drive connection, and that will bring it to 9 inches. Now, having said that, we need to look at dividing these panels up and figuring out how long they actually need to be. I'm just going to darken this a little bit. Okay. Now, because our working drawing has given me an outside view of the top, it's important for me to understand that the outside view of the top panel is also the inside view of the bottom panel. Now, I have an instruction here telling me the bottom is rising 2 inches. Therefore, my true length of the bottom panel has to be triangulated 2 inches on 7.25 inches. And I can see that in my working triangle here above my sketch. 7.25 is my working length. 2 inches is the fall of my panel. The true length of my bottom panel, therefore, is 7.25 squared plus 2 squared. Take the square root of that, and I get 7.5 inches. So the working length of the bottom panel is 7.5 inches. This means that I have to lay out my transition over 7.5 inches, add for my transverse connections, and when that panel falls, it's 2 inches, it will finish at 7.25 inches. Now, I've made a nice little sketch here of the bottom, and as you can see, I figured out this offset for the left side. And if we go back to our shop ticket, we can see that we have 8 on the ductmate side, plus a 3-inch offset for 11. And if I subtract the side I'm looking at here, which is 6, that will give me the offset here. So 8 and 3 is 11, minus 6 gives me 5. I now know that my left side is falling 5 inches. I can see that my right side is falling 3 inches, and my bottom is falling 2 inches. The top, we're going to figure out by laying out the left side. And here's how that works. I'm not sure of the fall of my top yet because I can't physically see it from these sketches that I've made. The information just isn't here. But if I come over and lay out my left side here, here's my 10 inches for the left side, where my ductmate's going to go. And if I lay out that 10 inches, it's important for me to realize that the right-hand side is going to be the bottom information where I'm going up 2 inches. And here you can see from this 10-inch side, I'm going up 2 inches. If I have my 10-inch side, 2-inch side, and then my 12-inch dimension here for a total of 14, that tells me that this has to be 4 inches. 12 plus 2, 14, minus 10 is 4. This is my bottom going up 2, this is my top. I now see that my top is moving up 4 inches. And I can put a 4 right here. Now that I put out my left side, all I have to do is flip it to get the mirror image to get my right side. So if I have 12, 2 here, I'm going to put 2 and 12 there. And everything flips around. Here's now, to the right side is the information from my top. Here's the information from my bottom. 2-inch offset, 4-inch offset. Next we need to calculate, Next we need to calculate the actual working length of each of these individual panels. Okay, well let's check. Here I have a bottom panel that is 7.25 on 2 inches and it's been marked here at 7.5. Let's just double check that. I have 7.25 squared. And to that I have to add 2 squared, which is 4, equals, and now I'm going to find the square root of that sum, and I get 7.5208, 7.5 inches is the true working length of my bottom panel. So we'll clear that now, and let's look at our top panel. It is 7.25, 7.25 squared, plus 4 squared equals, and now I have to take the square root of that sum, and I get 8.28024. So I know the true length of my top is 8, and I'm going to subtract 8. And let's multiply that by 1/12 of an inch for the drafting room. And I get 3 over 12, which is 1/4. So 8 and 1/4 is my true working length for my top. Let's clear that. And let's look at our left side. Left side is falling 5 inches. There it is here on the bottom view. It's falling 5 inches on 7 1/4. Therefore, 7.25 squared plus 5 squared is equal to 77.5625. I'm going to take the square root of that to get 6. I must have just squared that. Yeah, the square root of that to get 8.806. So true length on my left side is 8. And let's subtract 8 from that. Minus 8 equals decimal 806,957, and so on. And I'm going to multiply that by 12ths of an inch once again for my drafting room. And I get 9.610 over 12. 8, 10 over 12. And on our right side now, on our right side we have 7 1/4 for a working length, and our panel is falling 3 inches. Let's find out the true length. 7.25 squared plus 3 squared is equal to 61.5625. Now I need to take the square root of that for my actual length, and I get 7.846177. So that is equal to 7. And now we are going to subtract 7. And there's my decimal, and I'm going to multiply that by 12ths of an inch for the drafting room once again. And I get 10.15, which is 10 over 12 once again. 7 and 10 over 12. Okay, let's get rid of that. Now, we have the working lengths of all our fittings. We have a sketch that indicates how they should look from the inside. And we're ready to do our layout. Go to the next video.